There's a couple ways to try and find the vertex of a polynomial. One is to put it in standard form. A lot of your parabolas are going to come to you in this form, ax squared plus bx plus c. This form is really handy because you can look at this and determine, well, what's the vertex? So let's practice putting it in this form first, and then we'll talk about a different way to get the vertex beyond just putting it in this standard form. If you're going to put it in the standard form, we're going to need to do a process of completing the square. So for my convenience, I'm just going to move that 1 to the other side. Then I need to complete the square. So it's going to be 1 plus something plus something. Now to complete the square, I need to factor out the coefficient of my x squared term. So if I take a 2 out of this, I also have to take a 2 out of the 12x, or the minus 12x. What's going to be left behind in here? X squared minus 6x. And then a little plus something. We need to determine what we're going to put right here. And that process is the completing the square process we did in chapter 10. So let's think. To complete the square, we're not worried about the 2 at the moment. You take half of a particular number.
6.
Half of the negative 6, good. Half of negative 6 is negative 3.
Square.
And square the negative 3 gives me a positive 9. So I'm going to put that positive 9 in here. So I added 9 inside there, but I got to keep both sides of this equation equal. If I add something to one side, I got to add something to the other side. It's not going to be a 9 though. What's it going to be?
18.
18. 18 comes from the 2 times the 9. That's what I add to the left-hand side. Thank you, Julia.
Took me a while myself.
It's all right. You seem like it came up pretty quick. So that's going to be y plus 19 equals 2 times something squared. What do I square to get the right-hand side? What's that going to go? What am I going to put in here?
Negative 3, x minus.
Good. X minus 3. And finally, as a last step, I'm going to move that 19 back to the other side. Some people like to do it with keeping all that stuff on one side. I'm not a big fan. Get like something like that. Great. So here, I'd like you to be able to look at this and say, all right, now I know what the vertex is. So let's see what the vertex is. Vertex for that one's going to be, well, start with what makes the squared term equal to 0. What would I put in there to make the squared term equal to 0? This whole term.
3. Positive 3.
Positive 3. And if you made the squared term 0, so if I put in a 3 here, I'd get 3 minus 3, which is 0. Squared is still 0. Times 2 is still 0. 0 minus 19 gives me negative 19. So it's a skill that takes some work, but I'd like you to be able to read off the vertex in situations like this. If there's something uncomfortable about that, let me know and we can spend a little more time on it here.
So on the exam, will we need to know how to get the vertex to then complete an actual full problem? Or
So
how much will be given, I guess I'm asking.
So there's a couple things that I could ask. I could give you something like this and ask you to put it in standard form. I could give you in standard form and ask you to graph it, including the vertex, the x and y intercepts, and the axis of symmetry. We'll do that for this problem. But there's other ways to get the vertex here. And that's part of your question to me earlier and part of what I wanted to show you now, is that there's other ways to get the vertex. So, but just for one more example like this, if I gave you, for instance, y equals 3 times x plus 7 squared minus 21, then you would do kind of the same thing here to figure out what the vertex would be. You'd look at the squared term and you ask yourself, what value of x would make that squared term equal to 0? So in this case, Austin, what would that be? -7. If I put in a -7 here for x, then this becomes a 0. Squared is still 0. Times 3 is still 0. So when I put in -7 for x, I end up with -21 for y. So it's nice if you can just kind of read it off like that. But that's only going to happen when you have it in this form. What if it's given to you in this form and you still want the vertex? Well, there's a formula that you can use that Julia was talking about earlier, and that is you can do this. The x-coordinate of the vertex, assuming that your parabola is in this form, is given by x equals -b over 2a. So it's just a straight up formula. I could spend a minute or two deriving it for you, proving it to you. It's easier to prove once you've taken calculus, but for now, just trust me on this one. Let's see if it works though. So if I want the x-coordinate of the vertex, then let's work on it. So what's that going to be? You're going to have to go back up here to figure out a and b. This formula doesn't require that we use c. That's okay. So what are the values of a and b? 2 and -12. Nice. So 2 and -12, if I put that in, that becomes x is the negative of -12 divided by 2 times 2, which gives me positive 12 over 4, which is, wow, hey, cool, 3. So that's the x-coordinate of my vertex.
Of course, you can do that in lieu of doing y equals a times x minus h squared. If that's easier, is there ways, times when I would have to use?
Well, let me finish, and I'll let you, I think you'll be able to answer your own question. But if not, let me know and I'll help out. So that just gives me the x-coordinate of my vertex, right? How do you find the y-coordinate then?
Replace the 0. X is 0.
Not with 0.
3.
3. Yeah, we're going to plug in the 3 into this equation and find the y-coordinate. So if I want to find y, so find y, that's going to be y equals 2 times 3 squared minus 12 times 3 minus 1. So I'm going to take that 3 and plug it in here. And after I do all the math, I get 18 minus 36 minus 1. I'll end up with -19. Okay, so great. There's my vertex. So now I've got 3, -19 is my vertex. All right. Well, then what? Now I could ask you for the x and y intercepts, and we'll go over that in a second. But if I just gave you this equation, if I just gave you y equals 2x squared minus 12x minus 1, and I asked you to put it in standard form, if you've already taken the time to figure out what h and k are, so I've got 3 and -21, that's my h and k, spirit -19, sorry, 3 and -19, -19, that's my h, that's my k, so then I get y equals a, which I already know is 2, times x minus 3, that's my h. So 3 goes in there, and squared, plus k, which is negative 19. So in other words, you get 2 times x minus 3 squared minus 19. Just regarding the plus negative 19 as being minus 19. So if you can find the vertex, that gives you a different way to put it in this form. Now, let me make your life one little bit easier. What if, on the test, I allowed you to use Desmos? Then when you're graphing something like this, and like this, then there's this really cool feature on Desmos. You can just click here, and bam, that gives you your vertex. So, wow. Now let's see if we can't use that. What if I gave you, let me give you a different problem. Y equals 3 times x squared minus, I'll stick with the 12x again, plus 4 this time. And guess what? We can figure out the vertex. The vertex there is 2, negative 8. Does that make our life a little bit easier? A lot easier. Let's take a look at what that does for us. Let me rewrite the equation here for a second. Y equals 3x squared minus 12x minus 4. And I know that 2, negative 8, 2, negative 8, h and k, that's my vertex. So then can you put it into that standard form if you know it's the vertex? See if you can't rewrite it as something squared, something here, something there. Put it in that standard form now that you know h and k. This is a really nice shortcut. Really nice shortcut. Does anyone want to give it a shot? What would it look like? What number is going to be out front here?
3.
The 3. Good. So the 3 is going to be out in front. All right, so let's put you out in front. And then I'll have an x. And then what? Minus 2 squared plus negative 8, or better yet, minus 8. Negative 8, or 3 times x minus 2 squared minus 8. Wow, that's kind of cool. That's a nice savings of time. So if you pick up on that, that's great. In order to use Desmos on your exam, you've got to download to your phone or tablet Desmos test mode. All right. If you want to use that, download Desmos test mode, and I'll maybe help you practice using it. Let's go back to this one. So what we succeeded in doing is we've got y equals 2 times x squared minus 12x minus 1, or you could also write that as y equals 2 times x minus 3 squared minus 19. I would ask you for several things on a test. First, I'd ask you for the vertex. And for that, it's convenient to have it in this form. Hopefully you read off that that's 3 and negative 19. I'd also ask you for the y-intercepts. Actually, intercept. How do you find the y-intercept? Set x equal to 0. I'll give you a choice. Which one of these would you find it easier to set x equal to 0 in? The one on the left or the one on the right? Where's going to be easier to set x equal to 0?
On the left.
On the left, right? Because this term and this term, those disappear. So when x equals 0, what does y equal?
-1.
-1. Now I'm going to want the x-intercepts. And for the x-intercepts, you're going to set y equal to 0. So you've got two places you can do that. And here's again some more good review here for you in advance of the exam. I would solve each of these differently. They're both going to give you the same answer. How would you solve this first one? What would you do this Wednesday? Factor this one? I don't think that's going to factor. So if factoring doesn't work, what's your backup?
Quadratic form.
Quadratic formula. So that's going to be x is negative b plus or minus the square root of b squared minus 4ac all over 2a. Ugh. That doesn't look terribly fun, does it? A, B, and C. This is a tricky one in as much as you've got a couple negatives to deal with. In particular, what makes this one harder is that negative value for B. That's because it's very easy to make a mistake with this. By the way, for the exam, absolutely make sure you have this measure memorized correctly. Without it, there's just certain problems you're just going to fail on completely. You just can't do them without the quadratic formula. Not with what we've had in this class. So let's see. A is 2, B is negative 12, and C is negative 1. So that makes it a little bit messy plugging all this stuff in, because you've got these negative signs here and there. You got to be careful with them. I'd recommend filling it in with a bunch of empty parentheses first. So it's going to be the negative of B to start with. So the negative of negative 12. An easy place to make a mistake right off the bat is to forget the double negative. Because, you know, you got the negative B, subconsciously you can forget about that. It's also easy to make a mistake here. If you don't have parentheses, a lot of times people square that and get a negative 144 as opposed to a positive 144. Times A, which is 2, times C, which is negative 1, over 2 times A, which is 2. So I end up with 12 plus or minus the square root of 144. A minus times a plus times a minus. What sign am I going to put here?
Plus.
So it's going to be 12 plus or minus the square root of 152 over 4. Can I cancel the 12 and the 4? No. No. But here's on the test where you can earn some more points. And I'm sure I'll give you smaller numbers than this. I'm trying to think of the largest perfect square that would go into that. Might be just 4. 4 would go into there, what, 38 times? Yeah. So that's the square root of 4 times the square root of 38 over 4, which is 12 plus or minus 2 square roots of 38 over 4. Let's see. From here, I would factor out a 2 from the numerator. Again, I don't want to cancel. Even though there's a multiplication here, overall in the numerator, those terms are joined and I can't cancel into a plus or a minus like that. So that leaves behind 6 plus or minus the square root of 38 over 4. And finally, I can get that 2 to cancel. Onto the 6 plus or minus the square root of 38 over 2. And that's about as far as I can go with it until I come up with a numerical approximation. Alright. I could have solved it the other way. I could have solved it here. And it's important to take a look back at this to realize that, I don't know, it's your choice. But if it was up to me to solve, I'd solve it this way. You've got a squared term that you can put all by itself. Let me add 19 to both sides. And then divide both sides by 2. That's looking better. How would I solve in this case? What would you do now to finish solving? To get x by itself, or at least start getting x by itself.
Square.
Square root on both sides. And I'm going to run into one problem. And that is, I'm only going to get one solution. I know there's 2 solutions here. What did I forget?
That's right.
Plus or minus. Ah, okay. And now when I move the 3 to the side, I get 3 plus or minus the square root of 19 over 2 equals x. You ask yourself which one you like better. Do you like the quadratic formula and this, or do you like the square root property and this? They both give you, yeah, neither, all right.
No.
They both give you numerically the same answer. And that answer is going to be the last little piece up here. It's going to be 0 and 0. 3 plus the square root of 19 over 2, and 3 minus the square root of 19 over 2. If you were to calculate that decimal value, let's do that. 3 plus the square root of 19 over 2. Let's clear this up. Clear that. 3 plus square root of 19 over 2. I'm guessing 7 something. Oops. Like that. There we go. Oh, 6 something. Okay, yeah. All right. 6.082. And then the other solution, if I want to get the other solution, I'll just go back and change that to a minus. So minus there. And negative 0.08 something. If you look at the graph should be able to confirm that kind of stuff. So here's your 6 point, let's see, do I have that? No, this is the wrong one. All right, 2x, oh, it's this one, right? There we go. So here's your 6.08 something, and here's your negative 0.8 something. Those are your intercepts. Now, decimals can tell you, approximately what those are, and that's great. But keep in mind on the test, I'm going to want exact solutions. I'm going to want stuff like this. Okay. I think we did a lot in that example. I hope it covered all your questions. Yeah.